Now in example number 2, you've been told to prove the trigonometric identity sin b minus sin c over sin b plus sin c to be equivalent to tan b over minus c over 2 cot b plus c over 2. Now to prove this trigonometric identity, on the left hand side you can see there's a difference of two angles in the numerator over the sum, and the other side we have a product of two ratios. So that is a case of the factor formulas with the change of variables. So in factor formula with the change of variable, it means if you start with the numerator, we have sin b minus sin c. So if this is a case of factor formula, then this b, we can let maybe b to be x plus y and c to be x minus y. Or vice versa. You can as well say b is x minus y and c is x plus y. Then you use the symmetric identities to get rid of the negative numbers. Just like saying if you have sine of negative x, it's the same as negative sine x. If you have a case like cos of negative x, it's just the same as cos x, the symmetric identities. So that means when you take b to be x minus y, you can end up with this kind of scenarios. Or if you take b to be x plus y, you will still use symmetric identity, and at the end you get the same thing. So if you take b to be x plus y and c to be x minus y, then it will imply when you have sin b, is going to be sin, what is b? X plus y. So this is a sine sum angle formula. So sin x plus y is going to be sin x cos y. If here is positive, the other side is also positive, then you interchange, so it is now sin y cos x. Then sin c. So if you have sin c, that is sin, remember c is x minus y, so sin x minus y is going to be sine difference angle formula, so that is going to be sin x cos y, sin x cos y in that order. Then if here is negative, the other side is also negative. Then you interchange, so you now have sin y cos x. And what do we want? We want sin b minus sin c. So for us to get sin b minus sin c, meaning we get the difference of the two equations. So if we find the difference of the two equations, sin b minus sin c, on this side we get sin b minus sin c. The other side, this minus this. So sin x cos x minus sin x cos x is 0. Then sin y cos x, so there we remain sin y cos x minus negative. So that is plus. So we are now going to have 2 sin y cos x. If you find the difference of the two equations. So remember, difference of the two equations, this and this is the same. If you find the difference, you get 0. This minus negative, you get positive. So there are 2 of them. So from there, we've now found sin b minus sin c to be that. Then we also need sin b plus sin c. So what is sin b plus sin c? So sin b plus sin c, for us to get b plus c, meaning we add the two equations. So if we add the two equations, these are the equations we're using. If we subtract them, we get this. Then if we add them, we get this. So this plus this, you get that. Then this plus this. So sin x cos y plus sin x cos y, it means it is 2 sin x cos y. This plus this is 0 because positive and negative cancels out. So we've now found sin b minus sin c, and we also found sin b plus sin c. And remember, b was x plus y. So if b was x plus y and c was x minus y, we need b minus c. So for us to get b minus c, meaning we find the difference of the two equations. So the difference of the two equations will be b minus c is that is equals to x minus x is 0, positive y minus negative y. So positive y minus negative y, negative into negative is positive, that is 2y. So from here you can get y by dividing both sides by 2. So it implies y is b minus c over 2. So it means where there is y, we are going to put b minus c over 2. Then x. Then how do we get b plus c? Now b, for us to get b plus c, remember b is x plus y, c is x minus y. So to get b plus c, it means we add the two equations. So if you have the two equations, b plus c is going to be x plus x is 2x, positive y minus y is 0. So for you to get x, you divide both sides by 2. So you get x is b plus c over 2. So where there is x, we put b plus c over 2. Where there is y, we put b minus c over 2. So it means this is going to be equivalent to 2 sine y. But what is y? Y is b minus c over 2. So where there is y, we put b minus c over 2 cos x. And what is x? X is b plus c over 2. Then here again we have 2 sine x. What is x? B plus c over 2. Then cos y. Then our y is b minus c over 2. So we've now found sine b minus c, and we've also found sine b plus c. So we simply put, we found sine b minus sine c over sine b plus sine c. So substitute sine b minus sine c, we found is 2 sine b minus c over 2 cos b plus c over 2. Then it is over sine b plus sine c. Sine b plus sine c, we found is 2 sine b plus c over 2 cos b minus c over 2. So here 2 cancels out with the 2, we remain with this, so we can rearrange. So you see, we have sine b minus c over 2 and cos b minus c over 2. So we can rearrange. So in the numerator we have sine b minus c over 2 cos b plus c over 2, then over, so sine b, this and this, we can start with this factor. So we have cos b minus c over 2 times sine b plus c over 2. So this and this is the same as that and this. So from there, you now have sine over cos. Sine over cos is tan. So we have tan b minus c over 2. So sine b minus c over 2 over cos b minus c over 2, the whole of this gives you tan b minus c over 2. Then cos over sin is the reciprocal of tan, that is cot. So you get cot b plus c over 2. Cot b plus c over 2. So cos over sin is cot, sin over cos is tan. So remember the same angle inside b plus c over 2, b plus c over 2. So that is cot b plus c over 2. This is b minus c over 2, b minus c over 2. So that is exactly what is required. So to prove that kind of identity, it involves the procedure as applies in product identities and factor formulas.